Let's now look at just the last 100 years or so. Another argument is that most of the warming occurred between 1900 and 1940, and certainly there was warming in that period. But there was more warming from 1950 to the present or 1960 to the present than there was from 1900 to 1940. And the changes in the warming over time can be simulated, and we'll look at that by climate models. There's also an argument that, well, global average temperatures have cooled over the last 7 or 8 years, because if you look from 1998 to the present, as my friend and co-panel member Bob Carter said, climate has cooled over the last 7 or 8 years, because from 1998 to the present, 1998 was the warmest year in the global average record. Actually, if you fit a linear trend, as this diagram does, to the temperatures from 1998, it shows a warming trend. Yes, 1998 was the warmest year in the instrumental record, primarily because there was an El Nino event. And El Ninos warm the global climate system, and that was the largest El Nino in the whole record. So if you add that to the interannual variability, you get a big spike. It's just as bad to take the upper bound and say the climate has cooled over that period as to take the lower bound and say that the warming has been at the order of 3 or 4 tenths of a degree in 7 years. That is wrong. But if you average the temperatures, yes, there's a pronounced warming trend, and that warming trend has stayed much the same over the last 20 years or so. Let's look at greenhouse gas changes now. There have been massive increases in atmospheric concentrations of carbon dioxide and methane over the last 100 years or so, and they now exceed the values that we can determine from ice cores for at least the last 650,000 years, and we know that the increases are primarily due to fossil fuel use, agriculture, and land use changes. So how do we know that? Well, the myth is that the greenhouse gas increases are due to the same natural processes that lead to the greenhouse gas increases from an ice age to an interglacial period, or that they're due to volcanoes and they're not due to human activity. That's wrong. We know they're due to human activity because if we burn fossil fuels, we're oxidizing carbon. And if you oxidize something, you expect the oxygen concentrations to decrease. And that's what this diagram shows on the left. Oxygen concentrations have decreased where we have good decrease. Now, you don't have to worry, we're not going to run out of oxygen. There is plenty of oxygen in the atmosphere, but the decreases are exactly consistent with the increases in carbon dioxide. Burning fossil fuels is the main cause. We can also look at the oxygen isotopic ratio. That indicates we are seeing an increase in photosynthetically processed carbon dioxide, not carbon dioxide from volcanoes. And if you emit carbon dioxide from volcanoes, you don't get reductions in oxygen. And finally, there are reasonably good estimates of the volcanic sources for the last 100 years. And they're on average much, much less than the human sources. So no, it's not due to volcanoes, despite what former Melbourne University professor Ian Plimer says, or what Bob Carter says. They're wrong. Another myth. Climate scientists only consider increasing greenhouse gases. No. The IPCC and climate scientists consider all known causes of climate change, including changes in solar irradiance, land use change, aerosols, and they assess globally the relative importance from first principles as well as then in climate models. And this diagram shows over the period from pre-industrial times to the present the relative magnitudes of the different sources. How long have I been going?
You've still got
3?
5 minutes if we're very short on the question.
Okay, well I'm on going. So if we look at the relative magnitudes of the different causes, here is carbon dioxide, by far the largest. Here's the other greenhouse gases. Somewhere down here is solar, less than 1/10 the magnitude over the whole of the 20th century relative to the forcing due to greenhouse gases, including carbon dioxide. Some of the greenhouse gas radiative influence is offset by small particles in the atmosphere called aerosols, and they're a cooling influence. And that cooling influence is very important in understanding the time variations over the 20th century. So how can we understand the relative importance of the different forcing factors? Well, we could guess like Bob Carter or Ian Plimer do, or we could run climate models putting in different experiments, or we could wait and see what happens for another 200 years. Now, in practice, waiting 200 years may not be the best option. So what scientists like to do is they like to run multiple experiments with tools like climate models or with experiments that can simulate the climate system. So this shows two different sorts of experiments. It shows the observed temperatures as this thick line, and it shows a series of thin lines which are many tens of climate model simulations run with climate models from many centres around the world, more than 10 centres around the world. The top set show climate simulations with increasing greenhouse gases and aerosols and natural factors like volcanoes and changes in solar irradiance. The bottom set just changes with the natural factors. And you can see the influence of the volcanoes. There were three major volcanoes in the last 40 years. Agung in 63, El Chichon in 82, Pinatubo in 1991. They show cooling of the climate system. And the interesting thing is the climate models actually show the coolings here, here, and here at the same time as they were found in the observations. So the climate models are the bottom, and the top part is the observations, and the climate models agree with those cooling dips, but they don't show the warming over the last 50 years if just natural factors are included. Now, if we include in the top panel the increases in greenhouse gases and the other forcing factors, there's an excellent agreement, including, come on mouse, where have you gone? Well, I can point. If we look at the first 40 years, there's an excellent agreement for the warming in the first 40 years, and it's likely that natural factors were a substantial forcing factor. The reduction in warming from 1940 to 1960 is likely to be due to increases in the aerosols, due to increases in industrial activity, as well as the major volcanic eruptions Agung in 1963. So the myth is anthropogenic forcing can't explain the warming and the lack of warming. Well, yes, it can if you put the warming and the other, if you put the forcing factors, greenhouse gases, aerosols, and natural forcing factors. Yes, climate models do a good job. Yes, they can explain the observed decadal variation. What about solar? Well, solar's been argued that's the answer. It's all due to the sun because, look at the sun, it's a big forcing factor. Yes, it is big. Yes, solar radiation is critically important for heating the Earth. No, it is not critically important for explaining the warming over the last 50 years. Why? Because satellite observations show no long-term trend in solar irradiance for the last 30 years. They show a big 11-year cycle, but the observed temperatures don't show a big 11-year cycle in temperatures. Secondly, if solar irradiance was really important, then we'd expect more warming in the daytime, because that's when the sunlight's more important than in the nighttime, or more warming in summer than in winter. And that's exactly the opposite to what's observed, which is more warming at night and more warming in winter, which is exactly what you'd expect from changes in greenhouse gases. And finally, if solar irradiance was increasing, you'd expect more warming in the stratosphere because of absorption of solar radiation in the stratosphere. The stratosphere has been cooling, which is exactly what you'd expect from the cooling effect of increases in greenhouse gases. So to conclude, and all these conclusions in quotes, I should have pointed out, are quotes from the IPCC scientific assessment. Warming of the climate system over the last century is unequivocal. Atmospheric concentrations of carbon dioxide and other greenhouse gases far exceed their pre-industrial values and far exceed the values for the last 650,000 years. Those increases are primarily due to fossil fuel use, agriculture and land use change, and it's very likely, more than 90% certain, in a conservative estimate from the IPCC, that anthropogenic greenhouse gas increases have caused most of the observed increase in globally average temperatures over the last 50 years. So global warming due to human activity is real, and the myths from the climate change deniers are all false.